Hello everyone, welcome back to my YouTube channel. My name is Arnav Jain and I'm currently working as an SDE2 at Amazon. In this video, we are going to cover two very important solid principles: interface segregation principle and dependency inversion principle. In the previous videos, we already discussed what design patterns are, why solid principles are important to understand design patterns, single responsibility principle, open-closed principle, Liskov substitution principle. And in this video, we will complete the remaining two principles and finish solid end to end. So yeah, let's get started. Before jumping into interface segregation principle, we first need to understand what an interface is. An interface is nothing but a contract. It defines what a class should do, but not how it should do it. In Java, an interface contains method declarations, no method implementation, no method body, and all variables inside an interface are by default public, static, and final. Now let's take a simple example. Suppose I create an interface called worker. Inside this interface, I define two methods, work and eat. Important thing to note, I am only declaring these methods. I am not implementing them. To implement them, I need to create a class that implements this interface. Now let's say I create a class called robot worker. This class implements the worker interface. Now think logically. A robot can work, but does a robot eat? No. But since eat is part of the contract, the compiler forces me to implement it. If I only implement work and execute the code, the compiler throws an error saying, robot worker is not abstract and does not override abstract method eat in worker. Why? Because an interface is a contract, and if a class signs that contract, it must fulfill all the methods. So what do? We implement eat and maybe throw an exception like unsupported operation exception. Now the code compiles, but design-wise, it's bad because we are forcing robot worker to implement something it doesn't need. And this is exactly where the interface segregation principle comes into the picture. Interface segregation principle states a class should not be forced to depend on methods it does not use. In our example, robot worker is being forced to implement eat, which it doesn't need. That is a violation. So what's the solution? We break the fat interface into smaller, more specific interfaces. Instead of one big worker interface, we create workable interface row contains work, eatable interface row contains eat. Now things become clean. Robot worker implements only workable. Human worker implements both workable and eatable. Now, robot worker only implements work. Human worker implements both work and eat. Now if I execute the code, let's see what happens. If I create an object of robot worker and call robotworker.work, it executes successfully because robot worker only implements the workable interface and it only has the work method. So everything works perfectly fine. Similarly, if I create an object of human worker and call humanworker.work as well as humanworker.eat, both methods execute successfully. There are no unnecessary exceptions. There are no forced implementations. Each class is implementing only what it actually needs. And this is exactly what interface segregation principle is. We split large fat interfaces into smaller specific interfaces so that classes are not forced to depend on methods they don't use. Now let's move forward with the dependency inversion principle. Dependency inversion principle states that a class should depend on abstraction, not on implementation. In simple words, we should depend on interfaces, not on concrete classes. Now don't worry if this statement doesn't feel very clear right now. It might sound a little theoretical. So let's break it down with a simple example to understand it in depth. Suppose we have a class called email service. Inside this class, we have a method called send email, which takes a message as input and sends the email. Simple enough. Now we create another class called notification service. Inside notification service, we create an object of email service and we define a method called notify user. This notify user method calls email service.send email to send the message to the user. Now we create an object of notification service and we call notification service.notify user. When we execute the code, the output is sending email hello user. Everything works perfectly fine. So what's the problem? The problem is simple. Inside notification service, we are creating a private email service object. This creates tight coupling. Notification service is directly dependent on email service, and this is where the design issue begins. Now imagine tomorrow the requirement changes. Instead of sending email, we want to send SMS. What happens? We have to modify notification service. Later, if we want WhatsApp notifications, again we modify the same class, again and again. This violates two important solid principles. First, dependency inversion principle. Second, open-closed principle. Why? Because we are modifying the same class every time a new requirement comes. And that is not scalable design. So what is the solution? The solution is simple. Instead of directly depending on email service, we depend on something more generic. We create an interface called message service. Inside it, we declare a method called send message. Now we modify notification service. Instead of creating an email service object, we declare a variable of type message service, and we take message service as a constructor parameter. This means when notification service is created, it receives a message service object from outside. Inside the constructor, we assign this.message service equals message service. This is called constructor injection. Now inside notify user, instead of calling email service.send email, we call message service.send message. Now here is the beauty. Notification service no longer knows whether it is sending an email, an SMS, or a WhatsApp message. It only knows one thing, message service. Now comes an important change. Email service must implement message service. Instead of having send email, it implements the method defined in the interface send message. Inside that method, we write the logic to send email. So effectively, email service becomes a type of message service. Similarly, SMS service implements message service. All of them are simply different implementations of the same abstraction. Now in the main method, we create an object of message service and assign it an email service object. This works because email service implements message service. Then we create an object of notification service and pass the message service object to it. If we execute the code, the output is sending email hello user. Now suppose we want SMS instead. We change just one line. Instead of new email service, we write new SMS service. That's it. We execute the code and now the output is sending SMS hello user. Notice something important. We did not modify notification service, not even a single line. So what did we achieve? Notification service is no longer tightly coupled. It does not depend on email service, SMS service, or WhatsApp service. It depends only on the abstraction, message service. And that is exactly what dependency inversion principle says. Depend on abstractions, not on implementations. High-level modules should not depend on low-level modules. Both should depend on abstraction. In this example, notification service is the high-level module. Email service, SMS service, WhatsApp service are low-level modules. And all of them depend on the abstraction, message service. And when we say abstraction, we mean interface. So when we say depend on abstraction, not implementation, we mean depend on interfaces, not concrete classes. And that is dependency inversion principle in action. With this, we have now completed all the solid principles end to end. From the next video onwards, we will start focusing on creational design pattern. If you like this video, please like and subscribe to my channel. Your support really motivates me to create more high quality content like this and helps this channel grow. Thank you so much for watching. Stay connected, keep learning, and I'll see you in the next video.